Symmetry. Do you guys know what symmetry means?
The same, right?
Well, kind of.
The same on either side.
Yeah, that's right. What's something that is symmetrical,
Circle. Across.
like outside of geometry?
What?
What's circular?
What's something that's symmetrical that's not a geometrical? Like something in life.
The clock. What are you
Okay.
asking?
Smiley face.
Smiley face. Yeah, are we symmetrical?
No.
Mostly.
Kind of, pretty much.
Can be. Takes.
Mostly. So yeah, if you're right-handed, your right hand is like slightly bigger than your left hand. Yeah, it's pretty tiny. Or you have a little more musculature in your right side if you're right-handed. So you're not exactly similar, but, and also on the inside, everything's kind of, like your heart's a little over to the left and your stomach's like a little to the right and your gallbladder's up here. And so everything's kind of mixed around inside. But on the outside, we're pretty much symmetrical. Yeah. So there's something called a line of symmetry. Let's do a star. I think this might be one of the questions, but that's okay. I can't draw a perfect star. It's really hard. Can't be done. All right. Is a star symmetrical?
Yes.
Yeah. So the line of symmetry would be any line that like cuts it in half. So you can kind of tell if you fold a star over, does it look the same on both sides? It's really, it's like a reflection. Does it reflect the image on the opposite side? Yeah. If I folded the star over, it would be the same on both. Pretending it was perfect, it would be the same on both sides. Does this star have any other lines of symmetry?
Yeah. No.
It does.
Yeah, stars, or this kind of star anyway, if you turn your head sideways, they should look the same from all these different angles.
If it was a good star.
Yeah. Well, can I rotate on this?
Probably.
Let's see.
Blue dot. It's on blue dot.
Let's get it out of the way first. Yeah. So, line of symmetry there, line of symmetry there, line of symmetry there. Oh. Yeah. How many lines of symmetry does a star have?
5.
Yeah. Kind of goes, from each point down the opposite side. It's got 5 points of symmetry. Okay, so that's just normal symmetry. Actually, you can call it line symmetry. But if somebody uses the word symmetrical, that's what they mean, is have line symmetry. But we're not just doing line symmetry. We are also doing, have you guys talked about this in like science or something? Rotational symmetry?
No.
No? Okay. Rotationals, I have a memory last year, like the kids had heard of it before. Maybe you're about to do it in science or something. So rotational symmetry means if I rotate the shape, does it look the same again? So let's say I have an equilateral triangle. If I rotate the shape, darn it, I was hoping that was connected. Try again. There we go. If I rotate the shape, does it have an identical image eventually? Yes. So an equilateral triangle, it's got to be equilateral because it's got to be the same on every side. Does have rotational symmetry. How many degrees do I have to turn it before it looks like itself again?
120.
Well, yeah. In a full rotation is how many degrees? 360. So since this triangle is to cut up into like thirds, if I turn it a third of 360, it's the same again. So 360 divided by 3 is 120 degrees. Okay, yeah. What did they call that? Did they give a special name to that rotation? Okay, they call the 120 degrees the magnitude. I forgot about that. Like, that's how many degrees you have to turn it before it looks like itself again. Okay, if you turn something 180 degrees and it looks identical, like one of these is like a football or something. So if you, kind of like a lemon, if you turn this 180 degrees, how far is 180 degrees? Half a rotation. It looks identical again, right? So that's a kind of rotational symmetry, but it's specifically if it works at 180, it's called point symmetry. So point symmetry is basically rotational symmetry, but it's 180 degree rotational. Okay, does my equilateral triangle down here have point symmetry? If I turn it 180, will it look the same?
Yes. Wait, no.
No, if I turn it 180, this point is at the bottom instead of pointing up. So no, this has symmetry, rotational symmetry, but it doesn't have point symmetry. Because if you turn it upside down, it does not look the same as it did. The point's on the bottom instead of the top. All right. Okay. I think we're ready. Hopefully. Number 1, for each figure in exercise 1 through 12, state A, the number of lines of symmetry, B, the magnitude of any rotational symmetry, and C, whether it has point symmetry. So there's 3 questions. So on number 1, how many lines, there's my airplane there. How many lines of, what does the back of the airplane look like? It's kind of got like a little shark fin. How many lines of symmetry could we draw on this?
1.
Yeah.
Straight down the middle. Right
there. If you do this, it does not look the same as in the front and the back. So their first answer on 1 is 1. Does it have any rotational symmetry? Okay, if 360 would work on everything, so that doesn't count. So yeah, if you turn it, it does not look the same from any angle until you get back to 360. But 360 doesn't count because that's just putting it back where it started. So this is just going to be none. If it, yeah. So does it have any point symmetry? If it doesn't have any rotational symmetry, there's no way it'll have point symmetry. Point symmetry means a 180 rotational. So no, there is no point symmetry. Not 2. Number 3, kind of a weird puzzle, irregular shaped puzzle piece, right? Okay, how many lines of symmetry does that puzzle piece have? I'm not going to try to draw it. 0. It's too weirdly shaped. There's no mirror image on that. Does it have any rotational symmetry? No. So does it have any point symmetry? No. All right, let's take a straw poll. What do you guys think is happening on number 5? What is that a picture of?
Is there a bug or a plant?
I think bug, plant, and bug.
Bug, plant, combined. kind of reminds me of praying mantis, like maybe from above, with wings.
It's a book that got a plant attached to it.
Anyways, does it have any lines of symmetry?
One.
One, right down the middle. It's identical on both sides. I'm definitely not going to draw that one. Does it have any rotational symmetry? No. Looks like all the evens have all the rotational symmetry. Hope we get an odd in there. Okay, no, there's not. So if there's no rotational symmetry, there cannot be any point symmetry. If you turn that thing upside down like 180, it's not gonna look the same.
So what's point symmetry?
So if you turn it 180, does it look identical to what it did?
So then what's the magnitude thing?
Magnitude is how many degrees you have to turn it before it looks the same. Okay, does number 7 have any line symmetry? Or how many line symmetries are there? This one's kind of tricky. Any guesses? Like where could I draw a line on 7? Stop doing the evens, pay attention. Does this have any line symmetry?
Yeah. Two.
Where
Yeah.
could I draw it?
Sort of in the middle.
From
We
the-
slanted.
Like this?
No.
From the points.
Like
Corner
parallel
point.
to
Yeah,
the
from the
other two lines.
Parallel like this?
Yeah.
Okay. If I fold that this way, is it going to look identical?
No.
No. This would go down here. Okay. Anywhere else?
Straight up the, like diagonal up the middle maybe?
Like this?
No. But does that work? Oh wait, that, yeah.
Does it work?
No.
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 No, if you blow it up, it's wrong. 9, 0.
Yeah, there are none.
To the bar.
Okay. Does it have any rotational symmetry?
Nope.
Darn it.
Well,
I was hoping that was connected. If I draw it really fast, it'll be connected. Or if I just do a continuous line.
If you just don't disconnect it. Yes, it does. Yeah, one.
Yeah. How many degrees am I turning it before it looks identical?
180.
180. So, yeah, it actually does have rotational symmetry, 180. Does it have any point symmetry? Yeah.
Yeah.
So the definition of point symmetry is 180 rotational symmetry. So the second answer is 180. Now, the second answer doesn't always have to be 180. For example, a square. I don't think they gave a square. So I should have started with this as an example. How many lines of symmetry does a square have? Do you guys know? Yeah. 1, 2, 3, 4. Does it have any rotational symmetry?
Yeah.
How many degrees do you have to turn the square before it looks the same?
90.
Yeah, quarter turn, so it's 90 degrees. Does that have point symmetry? If you turn it 180, yeah. If you turn it 180 upside down, it looks the same. So, anyway, number 9. What's number 9 a picture of? It is a hubcap. Does it have any line symmetry? I'll kind of draw a rough sketch of that. Something like that, right?
Sure.
Does it have any line symmetry?
No.
No. If you try and split it down the middle, they don't really mirror each other quite right. Anywhere you split it, it doesn't look quite right. I didn't draw my little arrow thingies very well, but anyway, it doesn't work. So 0 line symmetry. Does it have rotational symmetry?
45 degrees?
Okay, how could we figure out, it does have rotational symmetry. If you turn the hubcap, it looks the same. If you turn it a little bit. How could we figure out how many degrees you have to turn it though?
Count the holes divided by 360.
Right, well, yeah, you said it backwards. 360 divided by those little triangular shapes. That's how far you have to turn it. How many triangles are there? 8. So it's 360 divided by 8, which is that a good guess, Natalie, or just
It was a really good guess.
it's a really good guess? Well, good job. Way to guess. Okay, does it have point symmetry? If we turn it exactly 180, is it going to work out?
No.
Okay, basically if this number goes into 180, like if you keep turning it 45, 45, 45, does 45 go into 180?
Yeah.
Yeah, it does. 45 times 2 is 90, so 45 times 4 is 1. Comes out perfectly. So yeah, it does actually have point symmetry. Number 11 looks like a logo, some kind of company. Must not be, or else. See how if you look at it at different angles, it looks like sun. Any idea what I'm talking about? No.
Yeah.
Does it have line symmetry? I'm not gonna draw that. It's taking me too long.
Yeah. No.
No, if you like split up the S and the U in and try and fold it over that line, it does not look the same. Or if you fold it from left to right, it doesn't look the same. So 11 doesn't. Not a lot of line symmetry. I think all the line symmetry is on the evens. You gotta be careful in those because they can be challenging. Does it have rotational symmetry?
Yes.
Yeah, if we turn it, how much of a turn do we need before it looks the same as it does?
90.
Yeah, it needs a quarter turn. So that left and the quarter of a turn is 90 degrees. Does it have point symmetry?
Yes.
Yeah, if we turn it 2 90s, that's 180. So yes, it has point symmetry. There's a smiley face. Number 13. I'm going to leave that one to you guys. Design a logo that has 2 lines of symmetry as well as rotational symmetry. So a logo is like, you can do whatever you want. No gang symbolism. Or no Nazi symbols or what have you. Anyway, I'm going to leave that to you guys. A swastika doesn't have line symmetry. It does have rotational though. Anyway, it doesn't have to be too complicated. I'll just look at it. If you want me to check it, I will. 15. For each aerial photograph, state the number of lines of symmetry, the magnitude, and whether it's point. So it's the same question as 1 through 12, basically. Does 15 have line symmetry?
Yes.
Did they draw lines in your book? They drew some in mine.
Nope.
Yeah, it does have line symmetry. If you draw a vertical line and split up those big circles, why don't you guys all try and count on 15, see if you can figure out how many. There's quite a few. Well, it'd take me a long time to try and draw that. I don't know what to do. All right, how many do you guys think there are?
9.
Nope, that's too many.
Too many?
Yeah. Remember, when you're going around the circle, make sure you don't count the same line twice. You know what I'm saying?
I
Like-
got that still.
Like, there's a vertical line would work for one of them, but you don't count the line again when you come around to the bottom. You know what I'm saying?
Yeah.
Are we doing 14 or 15?
15.
I still got 9.
Yeah, I got mine too.
Yeah, it's not 9. It's. Hang on. Let's see if I can draw that a little bit better. It's kind of like this. I can't do it. All right. So there's like a big circles here and here and here, but there's also some symmetry on these little circles.
Well, that's
Is it,
There's a
is
lot
it
of little
6?
circles.
Yeah, it is 6. That looks like a lot of lines, but it's actually just 6. It's horizontal and vertical and horizontal, I should say, and then kind of, yeah, there are 6 of them. Okay. So, how many degrees would we have to turn it before it looks identical? Well, I would count those big circles, like there's one at top, like at 12 o'clock. How many big circles are there going around though?
5,
6.
6, 5.
So that means, like, there's one here, there's one here, and there's one here. Anyways, we'd have to turn it like 1/6 of a turn for that big circle to get back up top. So it's 360 divided by 6.
60.
60 degrees, that's the second answer. 6 was the first answer. And does it have rotational symmetry?
Yes.
If we turned it 180, yeah, that'd be like 360s. So yes, it does have, or I said rotational, I meant point symmetry. All right, draw each figure and then draw all its lines of symmetry. Describe any rotational symmetry and identify the figures with point symmetry. It's kind of the same thing, but we're just drawing it ourselves. That's what's going on. 17, a regular octagon. Uh-oh. Can we draw a regular octagon? There's probably a page in the book somewhere that you could copy, but I don't know where it's at.
I just the one in the book.
What page was it on?
Ooh, I can find it. Page 656.
All right, there's one on 656 if you want to help. Or you can try and copy mine. Maybe make it a little prettier than mine. That's a stop sign. Okay. Step 1, they said draw all the lines of symmetry.
There's a lot.
Yeah, there's a lot. So we can go from like the middle of the segment to the middle of the segment, right? I don't know if I drew this neat enough. Okay, the question is, can we go from vertex to vertex?
Yeah.
Right? Yes.
Yes.
Let's see.
Maybe not on.
Well, my picture is kind of
It's a
screwed up.
little lopsided.
Let's see. Yeah, it's lopsided because I can't see very well. But on this side, basically, on this side of the diagonal, there's 4 of these, and on this side, there's 4. So yeah, I think it is the same. So we can do opposite diagonal to opposite, like opposite vertex to opposite vertex. Kind of a mess. You guys know how many I drew? Or how many there are? 8. 4 of them are splitting the sides in half, and 4 of them are going from vertex to vertex, corner to corner. Second question. It's kind of the same thing. Does it have rotational symmetry? How many degrees would we have to turn it?
45.
It'd be 1/8 of 360, right? 360 divided by 8 is 45. I did that one already. So it's got 45-degree rotational symmetry. And does it have point symmetry?
Yes.
Yeah, we kind of did that one earlier. 45 degrees does go into 180. So yeah, it does have point symmetry. Let's hope 19's easier. A circle with one diameter. Yeah, it is easier.
That's just a
Whoa.
circle with a line through it.
Yeah.
Yeah.
Like the equator. Last year somebody said it was a Pokeball. Does it have any line symmetry?
Yeah.
How many? Where?
2. Up and down and side to side.
Right. Right there would split it in half, and yeah, oh, on top of the diameter would split it in half.
Yeah.
The diameter is part of the picture, so you gotta. Anyways, what's the rotational symmetry?
180.
Yeah, if I take these lines back out, it won't look the same until you turn it all the way upside down.
Yep.
So it is 180 degrees. Does it have point symmetry?
Yes.
Yeah. 21. A kite. Alright. You guys remember the definition of a kite? I kind of find these hard to draw, but let's see. That was pretty good.
No.
I have some.
The definition is it's got two pairs of congruent consecutive sides or something like that. Like these two are the same and these two are the same. Okay, are there any lines of symmetry?
2.
Wait, no, one.
One.
Sorry.
One. If you try and split it right here, this will be like,
Like,
big. Won't be the same. But this one, yeah, it's symmetrical around that. Does it have any rotational symmetry?
No.
No.
No. It has to go all the way back to
360.
360, so that's a no. So if there's no rotational symmetry, there's no way there could be point symmetry. Let's go fly a kite. 23. Does a figure with 90-degree rotational symmetry also have point symmetry?
Yes.
Yeah, because you can turn it 90 twice to get 180. So 23 is just yes. And send it so